Hello everyone, and welcome to the AI Research Roundup. I'm your host Alex, and today is May 9th, 2025. We're looking at an ICLR conference paper, PathGen 1.6M, 1.6 million pathology image text pairs generation through multi-agent collaboration, published just over 3 months ago. This paper addresses the critical need for high-quality data to train vision language models, or VLMs, AI that understands both images and text, and large multimodal models, or LMMs, similar large AI for multiple data types. The authors use a multi-agent AI system to create this data from whole slide images, which are super detailed digital scans of microscope slides. Alright, this first figure really highlights the scale and impact. On the left, PathGen's 1.6 million image text pairs dwarf other datasets. The middle radar chart then shows PathGen clip. Clip here means contrastive language image pre-training, a way for models to link images and text, and this specific vision language model performs impressively. To its right, PathGen LLaVA, that's Large Language and Vision Assistant, another top-performing large multimodal model, also shines. These visuals clearly show the new dataset's power. Okay, so this next figure, Figure 2, illustrates the clever multi-agent pipeline they designed. It starts on the left with representative patch extraction. Here they take those detailed whole slide images, break them into smaller patches, and use contrastive language image pre-training for cross-modal retrieval, essentially matching image patches to text from reports and specific attributes. They also use clustering, an AI technique to group similar items to ensure a diverse set of patches. Then, on the right, description generation kicks in, where different large multimodal model agents collaborate to write, revise, and finally summarize detailed descriptions for these selected patches. Building on that description generation process, this table, Table 1 from page 5, then shows us a human evaluation. It compares the image captions from PathGen 1.6M with those from another dataset, OpenPath. Two pathologists checked the accuracy, essentially the proportion of correct details in each caption. For PathGen 1.6M, they found accuracies of 90.3% and 88.5%, much higher than OpenPath scores in the mid-70s. Plus, PathGen captions averaged more findings, 5.3 compared to just over 2 for OpenPath, highlighting the new dataset's superior quality and detail. So after seeing how accurate the generated captions are, this next table, Table 2 from page 6, shifts focus to model performance. It compares different contrastive language image pre-training models on zero-shot pathology image classification. Zero-shot classification. Well, that's when a model has to identify types of images it wasn't specifically trained on. The results show the PathGen clip models, particularly PathGen clip-L, perform exceptionally well. PathGen clip-L achieves an impressive average accuracy of 79.7% across 9 different tasks, clearly outperforming other models. This strong performance highlights the quality of the new dataset. Following on from that strong zero-shot performance, this next figure, Figure 3 from page 7, shows us how these contrastive language image pre-training models do with few-shot classification. Few-shot classification, well, that's when models learn from just a tiny number of examples per category, like only 2 or 8. Across 4 different datasets, including LC: and Chameleon 17, the box plots reveal that the PathGen clip models, particularly PathGen clip-L, consistently achieve higher accuracy. This demonstrates they learn very effectively, even with minimal training data, which is a significant advantage. Alright, so moving beyond few-shot learning, this table, Table 3 from page 8, dives into whole slide image classification. It compares different contrastive language image pre-training models across 3 datasets using 2 multiple instance learning methods. Multiple instance learning, well, that's a technique where the AI learns from entire collections of image patches, like from a whole slide image, rather than needing each tiny patch to be individually labeled. Looking at performance metrics like F1 score, and especially the average area under the curve, or AUC, a key score for how well a model distinguishes classes. PathGen clip-L, the author's model, hits 92.6% with the ACMIL method, outperforming others. So in conclusion, after seeing its strong performance in whole slide image classification, this research really highlights a couple of key things. First, this multi-agent collaboration approach. It's a powerful and scalable way to create large, high-quality datasets of pathology images and text. Second, the resulting PathGen 1.6M dataset significantly boosts how well specialized vision language models, or VLMs, which are AI systems designed to understand both images and text, and large multimodal models perform across many pathology tasks. It's clear this dataset is a valuable new resource. That's all for this AI Research Roundup. Thanks for tuning in.